Thank you, Mr. Chairman. Good afternoon. And thank you, Raphael. Really warm and interesting presentation of Via Motori and our engine that we have in common, and also your insight on the North American market. And I will also say that if you come to this room with the ambition to grow from a small fish to a big fish, you have a lot of like-minded friends and sympathizers. And I don't know if you are aware, but your engine was the 5th engine for SinterCast that cracked the 100,000 engine equivalent barrier. So at least in our eyes, you already are a big fish. Okay. So thank you for taking your time to come and to support our annual meeting. And thank you for your support of CGI and your confidence in us.
Thank you.
Yeah, really great. Thank you. Let's start today with this familiar plot where we look at the development of our production, much like what Raphael did with the development at Via Motori, from 2007 until the present. And we see back in 2007, we had a stable production, primarily from the Ford and the Audi V6s. The production then increased with the onset of commercial vehicle programs. But unfortunately, as the lightning bolt in Raphael's presentation, we got hit by the economic crisis in the US and the global crisis. From that point, we started to grow, and that wasn't really a recovery. This was primarily the Ford 6.7-liter V8 for Super Duties coming on stream and ramping up. Recovery of the programs came later in this upward trend. We reached a peak of around 1.6 million, and then again a hit, and this was now the European economic downturn. It was actually two things. As many of you know, it was a suspended production of the Navistar 13-liter because of the emissions compliance, but also the pressure on the commercial vehicle programs here in Europe. From that, again, we grew, and now this time it was a recovery. It was a recovery with the restart of Navistar. It was 2 new programs coming on stream here in Europe, and of course the Via Motori block and bed plate contributing to that growth. And for the last year we've been rather strong and stable, currently at 1.7 million engine equivalents. And it's kind of fun for us inside of SinterCast because every month now when the foundries are reporting their production, we wonder if perhaps this month will be a new record. You know, if we can surpass the 1.8 million that we achieved back in October. Daphne and I, a couple of weeks ago, were meeting with an analyst here in Stockholm, and he said that he liked our company. And the reason that he liked the company was, he said, it's difficult to find companies with more than 10% growth. And we looked at each other and we said, you know, we're always above 10%. And so for today's presentation, I made a little calculation of our compounded annual growth rate from 2007 through until this year, and you see that we're rather consistently above 20%. And as an engineer, I don't want to take averages of averages. You know, that's wrong math, but you can see that the average is solidly above 20%. And we're very happy that we've been able to maintain that growth rate even as the production base is increased. You know, as the denominator increases, it's more difficult to have a high percent growth. You can have growth in absolute terms, but the percentage is challenging. So I think we've done a really good job at maintaining the growth. We can look at the production in a different way. This is the last reported results, the first quarter results as we come into the annual meeting. And here we see the record production of 1.7 million engine equivalents in the first quarter of this year, and also the 30% year-on-year growth. And we can break down where that growth has come from. Last year at this time, as I said, we were struggling with the trucks, both the Navistar and the European commercial vehicle programs, and we had this unusually heavy weighting on the car programs. So it was 65% car, 25% truck, and 10% other. And when we say other, we mean others, first of all, automotive components other than block and head, and industrial power components. And we'll come back and talk about those in more detail during the presentation. This year, thanks to the improvement on the truck side, we have a healthier balance, you know, back to where we normally have been with 54% car, 38% truck, and the other components hanging on there at around 10%. And I think that that's a good ambition for us, is that as the other programs continue to grow, that the others should try to stay at 10%. It's a tough target, but it's a reasonable target. Perhaps it's easier to see the growth by looking at the absolute numbers rather than the percent splits. And here we see the absolute numbers. So in the last year, cars have grown by approximately 10%. Trucks have effectively doubled from 330,000 engine equivalents to 650,000. And again, the others hanging on there at a stable rate. But as I say, we don't want them to be stable in terms of numbers. We want them to be maintaining the 10% level, and therefore they have a burden to grow as the rest of the production grows. So let's look at the different programs in more detail now. First, with the existing programs, as I said, we're currently running at 1.7 million engine equivalents. That was a record for the first quarter. We expect that that will continue to grow. Last year at the AGM, we said that the programs that are currently in series production have the potential to go above 2 million engine equivalents per year. This year in the first quarter report, we said that the current programs have the potential to go to more than 2.5 million engine equivalents. So you see that growth. And many of you know that back in March, I supported an analyst call for Tupy, our largest foundry customer in Brazil. And in the invitation to that call, Tupy said that they expected their automotive CGI to grow from 16% of their current production to 25% of their current production. And if you do that math, if you do that math, that corresponds to 750,000 engine equivalents. So you can see that they have a similar view on the growth potential. Much of the growth, as Raphael referred to, is coming now in the near term from the U.S. pickup trucks. U.S. pickup truck sector grew 17% last year in a market that grew about 5%. And we often wonder, especially here in Europe, is that unusual? Have the Americans got that wrong? Are the vehicles too big? And as Raphael said, people like to drive big vehicles. People like to drive comfortable vehicles. And it's the same here in Europe. Last year, SUVs were the fastest growing sector. And it's also the same in China. The Chinese economy last year grew by 7%. The auto industry grew by 14%. And SUVs grew by 53%. And it's interesting that for first-time car buyers, 60% of them chose an SUV. So you see, it's very common. And we can look then at the production in North America for the first 4 months of the year, and this comes from Automotive News, and you see that pickups are the top 3 vehicles. Yeah? And we're in 2 out of the 3 of them. Last year when we came together at the AGM, Ram was number 5. It's grown in popularity. It's now number 3. And in March, the first full month of sales, as Raphael is saying, it actually became number 2. Yeah? And a lot of times people will ask us, as the emissions goes up, and some of the questions that we had in the previous presentation, will pickups be able to maintain their volume? Is it possible to meet the emissions legislation? And so I've cut and pasted a little section from the Pricewaterhouse Auto Analyst forecast. And here you can see that through 2013 to 2018, those same 3 pickups are forecast to be the 3 best-selling vehicles in North America. And we're in 3 of those, so we're very well positioned. Let's look at commercial vehicles. Commercial vehicles is a sector which needs higher strength. There's higher pressure, higher horsepower, higher performance, so it's well suited to CGI. And as you see in the last year, we effectively doubled our production. That was because of the restart of the Navistar and also because of these new European programs coming on stream. So I wouldn't say that it was related to an economic recovery in the last 12 months, but there's a potential for that in the next 12 months. The European commercial vehicle market is forecast to grow approximately 5% this year. So that's the first growth in 6 years. and potentially more than 10% next year. So I think we can benefit from these new programs being launched and their ramp up, but also a contribution from the improvement of the economy. The European auto industry is also forecast to grow this year for the first time in 6 years. So, a little bit of light on the horizon. While Europe is doing well, China is struggling a little bit on the commercial vehicle side. There is a clear overcapacity in the market. Many of the OEMs have gone to reduced work weeks to try to balance the too high stock and the too low demand. And it's caused an uncertainty in the market about the timing for introducing new products. So it's still a huge commercial vehicle market. Approximately half of all commercial vehicles in the world are built and sold in China. So it's a great growth opportunity. But I think that we just have to ride along that bumpy water for a little while in China and see how it shakes out. Currently, our production is 650,000 engine equivalents in a total market of approximately 12 million engine equivalents. So that's approximately a 5% penetration rate. And if we think only of the Western market, because we're not yet selling any commercial vehicle components in China, so we change the denominator, we have about 15% penetration. And so it's a really good start, but more importantly, there's so much growth opportunity. When we're only sitting between 5 and 15%, we have so much to grow into without changing or doing anything differently, just serving the needs of that market. The petrol engine. 2 years ago, we first announced the first commitment for a high-volume petrol engine in CGI. And earlier this year at the Detroit Auto Show, Ford confirmed it and announced it as part of next year's F-150, which you saw previously, best-selling vehicle in North America. This engine is not only going to be the first high-volume petrol engine, but it's also destined to be the highest volume CGI engine in the world. And now I think a lot of people have connected the press release that we made at the Tupi Saltillo foundry in Mexico with this petrol engine production. And in that press release, we said that the production requirement was 9.2 hours per day, 16 ladles per hour. So that's one ladle or one pot of iron, more or less every 4 minutes. And that pot is just over 2 tons. So imagine that we'll be pouring more than 500 kilograms of iron every minute to satisfy the burden of this program. So it's truly, truly high volume. Of course, it's a part of our growth from 1.7 to more than 2.5, and it's also a part of Tupi's growth from the current 16% CGI to 25% CGI. The engine has been published now, and many of you will have seen it in Car and Driver in North America. And as it has been published, I thought that we could also take the opportunity to show the uniqueness and the clever, creative design. So we begin as a reference with this conventional block. This is our 2.7-liter V6 diesel that we make for Ford. Yeah? And this is what we call a traditional deep skirt design. So you see the cylinder banks at the top, but the engine block continues down and it encloses the crankshaft area and the oil. And it reaches all the way down to the oil pan at the bottom of the block. Yeah? There is a different philosophy for making engines, where you basically cut the engine at the halfway point and put on a bed plate, which is exactly what VM Motori does. This is a so-called short skirt design. And what Ford has done in this new approach is to cast the entire internal load-bearing structure together as one piece. So we have the cylinder banks at the top, but also extending down to the main bearings that hold the crankshaft in place. And then what they have done is just to add this aluminum cradle to enclose the engine. It's not doing any of the load, it's just enclosing and containing the oil. Yeah? So what do you think? We have one engine person in the room. What do you think of it, Raf, as a new design?
It's the answer to high performance and lightweight. It's genius, in my opinion.
Yeah.
It's a gasoline engine, so it's different than diesel.
Yeah.
I don't know if this would apply to diesel, but I think many engineers are thinking about it.
And it is a very good
Now
point.
It seems obvious.
Well, that's exactly what so many people have said. You know, I wouldn't have thought of it myself, but when I see it, it's obvious.
Yes.
And so I think people are more inclined to follow things that make sense and that are logical and clear and obvious. And so we're quite hopeful for this follower reaction. And yeah, it's a really exciting program. The next step is that they will start to publish performance details, you know, somewhere middle of the year. So it means power and torque and weight and size and, of course, fuel economy. And then after that, the showroom sales will begin, and they're meant to begin later this year. So really an exciting thing, and we're really happy to be a part of it. And of course, when the OEM says, can you do 9.2 hours a day, 1 ladle every 4 minutes, you just say yes. And worry about it later. Now, interestingly, it was introduced as part of the all-aluminum F-150. And it's a bit disappointing that most of the media attention has been focused on the aluminum body. And they say that they've saved 700 pounds, 320 kilos in the vehicle. And I want to confirm that our engine, compared to the current base, is a part of that 320 kilo weight saving. So we've contributed to that. And a couple of weeks ago, I read an article which said that when Ford owned Jaguar Land Rover, they helped Jaguar Land Rover set up the aluminum body facility in the UK. And now after some years, and as you know, Jaguar Land Rover is no longer a Ford ownership, the Ford engineers have been invited back to benchmark and to learn to help them with the F-150. And I got to thinking, you know, there's a lot of aluminum-bodied vehicles, the Audi A8, the Range Rover, the Jaguar XJ, and the F-150. And what do all of those vehicles have in common? Well, they all have CGI engines. And for me, this is the most powerful statement about the benefits of CGI. Wouldn't you think that in these vehicles that are so open to the use of aluminum, that if they could have achieved the power density and the performance that they wanted, that they also would have used aluminum in the engine? You know, and it's unfortunate that that story isn't being told perhaps as well as it could have been. So we'll keep telling it. Beyond the 5 waves in this other category, as I say, we have automotive components other than block and head. That includes Raphael's bed plate. It also includes the exhaust components that we produce in China, turbocharger housings and exhaust manifold. The bed plate is obviously a growth contributor. The exhaust manifolds have been a very good runner for us, and they continue to contribute well. But I'm not sure that they are an obvious growth opportunity for the future. What is happening in engine technology is that the exhaust temperatures keep going up to try to improve the emissions. And as the exhaust temperatures go up, they reach the limit of cast iron. And this isn't a limit of CGI, this is a limit of iron. And you know, normally we're talking about the strength and the stiffness and the thermal conductivity, but this is about the atomic structure. And I think that we'll continue to have CGI applications in this, but as I say, not a growth, because more and more these will perhaps move to stainless steel or even water-cooled aluminum. But it's been a very good contributor for us, and I think it will continue to run at this rate. Therefore, we need more contribution from the industrial power side if we're to maintain our 10% ambition. And the industrial power side is marine, as we saw in the previous presentation, mining, construction, agriculture, and also stationary power generation, and rail. 12 of our 39 installations are currently in foundries devoted to industrial power. So, you know, we've established a really good base for that. The undisclosed installation that we announced in January is industrial power application. You may recall the MTU press release. It's for an engine for mining trucks, announced on 29 January, again, industrial power. So we do see that this can be a growth contributor. And that 10% level, I say it's a tough target, but you have to set the targets tough, and I think it's a reasonable target. Installations, well, let's step back a little bit. I said 12 out of 39. Imagine 39 installations. There's a lot of familiar faces in the crowd. If you look back some years, would we have thought that we would have 39 installations, 55 components in series production, 1.7 million engine equivalents growing to more than 2.5? You know, it's a really good progress and a really good foundation for the future. We've just had our 3 strongest years of installations, so now we focus on rebuilding that pipe and growing more foundries into the SinterCast camp. You know, this is where we really sell. Of course, we're out promoting CGI and we're knocking on doors of car and truck OEMs and industrial power OEMs, but there's too many of those to go to every door. And there's always a risk that if we motivate a new CGI engine that it doesn't come to a SinterCast foundry. So where we really sell is trying to lock foundries into the SinterCast camp so that when they win an order and when it comes to that foundry, it automatically comes to SinterCast. And so there's a real drive now to refill the pipe and continue to grow the footprint. I'd like to talk a little bit about the ductile iron technology. I have referred to it in the last couple of internet interviews after our 4Q and our 1Q reports. We acknowledge that this program is delayed. The simple fact is that the CGI side of the business became really busy over the last 6 or 8 months. A lot of new installations that were bigger than normal and had new functionality. And we just had to apply our technical people to developing those installations and making sure that we could serve the core CGI requirement. I'm quite happy with the correlations, and indeed we've shown the technical correlations to industry people and they've responded positively. We do have ongoing discussions about how to introduce the technology, both internally and externally. And in fact, we'll make the next trial tomorrow. And the trial is partially for technical reasons, but as many of you know from the 1Q report, we've recently hired a new senior research engineer, and the intention of this trial is to get him stuck into that project. And I'm happy to report that we've also recruited another engineer. It's a new graduate from KTH here in Stockholm who will join us this summer. So, you know, we're putting more resources on this project to try to push it forward. Many of you will be familiar with this plot, this so-called S-curve that you see in our CGI literature. And we can see the narrow stable range for CGI in this narrow magnesium window. But as you add more magnesium, you can see the ductile range up in the far right corner. And ductile iron has always had the advantage for foundries that they can add a little bit extra to play safe. Yeah? And so the foundries tend to run in a fairly wide range and to stay well above this dashed line for the minimum of ductile iron. And what we're trying to do with our technology is to improve the consistency so that we make the range smaller and also shift it down to a lower level. Because as you add more magnesium, of course there's a cost for the magnesium, but more magnesium also makes more defects. Yeah, it floats to the surface as little dirt particles and it makes the iron shrink more. So if you can run with less, you can also run more efficiently. This consistency has a value, and the ductile iron technology has the same burden as our CGI technology. It has to pay for itself. So we have to show the customers that by using our measurement that they can save money. And how we do that, as I said, they will decrease the alloys, primarily the magnesium. They will decrease the amount of porosity. As a casting shrinks, you need a feed reservoir to feed liquid iron into it to keep the mold filled. And if it will shrink less, we can make this reservoir smaller and therefore less cost. And these magnesium oxide and sulfide particles that float to the surface and get into the casting, and this dirt, this slag and dross that can cause weakness, crack initiation, the failure point for a casting. And at the same time, we can increase the mold yield. If you don't have to feed as much, it means more of what the foundry melts can be sold to the customer. The consistency, designers have to design for the worst case scenario. Yeah, so they're always designing for what they think might happen on a bad day. And if we can improve the bad days, then the designer can design lighter, more efficient, more aggressive components. And there's a real value in that. And also for machining. You know, CGI has always been a difficult material to machine. Ductile iron is, of course, more difficult to machine. And often machining people will say, we don't care what you give us, just give us the same thing every day. And that's what we're trying to do. Here you see the result screen that we've been using in our field trials. Many of you will recognize it as the SinterCast screen for CGI and the SinterCast branding. In the top left, we have the ladle by ladle results. And the new thing, this in the SinterCast colors along the bottom, this is the prediction of what the foundry should see if they were to cut the casting and look under the microscope. Yeah, so we're trying to give them that feedback before they need to destroy the casting and take the time and the cost to look under the microscope. We don't know entirely how foundries will use this technology. We're just trying to give them a better measurement to help them. They can use this information at the top to adjust the ladle before they cast it, to feed forward a control action, or to feed information back in the process to prepare the next ladle more efficiently. So they can use it for process control, much like we do for CGI. And they can also use this data, hopefully with the same accuracy as looking under the microscope, for quality control. And another possible application is spot testing. You know, when foundries have 4% scrap, it's not that they're running 4% every day. You know, they'll run perfectly well for days or even weeks, and then the bottom falls out. And the foundry that is successful is the foundry that can find out what happened quickly and fix it. And if they can measure the iron and have a better insight to it, they can respond more quickly. So there's a lot of different ways that foundries can potentially apply the technology. So in summary, we're running at 1.7, potential to grow to more than 2.5. So we've never had that high of a starting point in the past, and we'll benefit from that all through the year. Really exciting time for US pickups with the Ram already starting sales, the F-150 coming later this year, and the Nissan Titan coming next year. Also exciting for the petrol engine. We get the performance data probably toward the end of the summer, showroom later in the year, and we get to see this consumer response and media reaction to it and the follower reaction. We're busy rebuilding the installation pipe, trying to grow the footprint to ensure that more programs come to SinterCast. And the ductile iron development, well, we're addressing that by bringing new resources so that we can put more energy into the program and push it further and faster. So it's all very positive and motivating. And this thing that many of us believed in long ago, that we thought we could do technically, it's now worked. And we see that it's worked. And it's very motivating to see those vehicles on the road. And we feel the support and the appreciation of the shareholders. Thank you for that. We feel the respect and the acceptance of our foundry customers and our OEM customers. And as I say, it's an interesting and fun thing to do, and we look forward to doing more of it. Thank you.